Hello grade 12s, welcome to yet another video, and today we're going to be looking at the physical science common test that was written in KZN. This was a request by one of you guys, so I hope you'll be watching and that you will gain parts of the explanations you probably required. And for those who are practicing for the June exams, May June exams, as an upgrade or something, it may also give you a bit of a test to check whether you are within reach of what is expected of you in that exam. Alright guys, I'm not going to waste time at all. So this was a 2-hour paper, so we are given all the topography of the paper and exactly what is expected of you in attempting to answer these questions. Of course, this instruction right here is forever important. Show all formulae, substitutions, and all calculations, because in physical science these are mark scoring points. And then of course this one you always need to keep in mind. I told you to round off our numerical answers to a minimum of 2 decimal places. Minimum means 2 or more, okay, but no less than 2. Then of course give brief motivations, discussions, and absolutely anything that is acceptable in physics in explaining or expanding an idea. And then of course you're just advised to use the data sheet in case you run into a curve out of commission, but nonetheless you're not forced to write any formula in the way that it appears there. I know a lot of people tell you that you have to copy it as it is. No, that's not true, but that is just the safest maneuver for you to not lose marks unnecessarily. But you're not bound nor forced to write it as it appears there. As long as you know what you're doing and it is correct, it's risk-free, you can do it, okay? So don't be like a horse running a marathon here and look around you and just use whatever is available to you. Anyway, we've read the instructions and all that. I'm not going to repeat this. These are fairly standard, but be careful. Don't underestimate this instruction. Please read it carefully. At times they can swing it a bit because they know you will overlook it. They will swing it a bit and give you a few issues if you're not careful. So let's look at 1.1. We are told here a body slides along a frictionless, horizontal surface at constant velocity. Now that is most important. Constant velocity. So what do we know about constant velocity? It means the resultant force is equal to 0. And in effect, it means the acceleration is also equal to 0. Okay, great. It means all forces acting on this object are perfectly balanced, meaning the system is in equilibrium. So there's a lot you can say here from just that statement alone. Now, for which one of the following pairs, we're looking for a pair of things here, are the magnitudes of both physical quantities 0? So obviously we know that it is the resultant force and essentially the acceleration. So this question is basically just what we interpreted. Displacement and momentum. It definitely has momentum because it has a velocity, and it will certainly move a distance or a displacement. So these ones are non-zero. Acceleration and momentum, yes, acceleration, but momentum is non-zero. So that is just a problem. Displacement and the net force. The problem is the displacement, but the net force is correct. So now this combination is the one we are looking for. We know that the acceleration as well as the resultant force are both 0. Now a satellite orbits the Earth at a point X. So there is that point. where the gravitational force is a quarter of the gravitational force it experiences on the surface of the Earth. Okay, great, not a problem. So the question says now, if the radius of the Earth is r, okay, then the height of the satellite above the surface of the Earth will be. Now these are some questions you cannot just look in and have an answer. You've got to work it out. So what do we know? Newton's law of universal gravitation tells us that the gravitational force Fg is the capital letter G, the m1, m2 over r squared, which is the distance between these two objects. Okay, now that is what we understand. And in fact, this, if we adapt it to this object sitting here, let's say the satellite is sitting here, for example, on the surface of the Earth. So the distance between the center of the Earth and the center of the satellite right there will essentially be r, isn't it? Great. So we know that this Fg will essentially be the capital letter G, m1, m2, whichever it is, and then the distance between them is the capital letter r squared. So that's what we wanted to know. So this is the force on the surface of the Earth between these two objects, which is the Earth, the center of the Earth, and the satellite. But now the satellite is sitting right up there. Okay, and then the question is, what is this height? Okay, we want to know that height. Oh, this thing is about to irritate me. Okay, so we want to know this height. What is this height right here? Now we can tell that, okay, we are told something, that this force, when this satellite is at that point x, it is a quarter of this one. Okay, so what does that mean? It simply means our force of gravity in that instance, you know, is going to be a quarter of this one. A quarter of this is just to multiply by a quarter of G m1. This thing is about to irritate me now. I don't know why. This blinking business is about to drive me nuts. Okay, I'm sorry for the language, but yeah, that's just the frustration I'm getting. Now we know that this force Fg between these two is a quarter of that on Earth, which is going to be this. And then if we just simply do multiplication as we know it, it's going to be essentially G m1 m2 over 4r squared. Okay, maybe let's write r properly. Okay, 4r squared. And then now when we want to know the distance between the center of the Earth and that point x, we know that therefore the distance is going to be the square root of 4r, isn't it? Yes. You take the square root of that, and then it gives us the distance between the center of the Earth and that point x. So basically this is just doing this distance. Okay, that is the distance we're talking about here. Yeah, it's doing me a lot of disservice here. So now what is this going to be equal to? It's going to be 2r. Sorry, this is 4r squared. So this is going to give us 2r. So we've got 2r here. But we already know that this is r. So it means our h is basically going to be this distance d minus r, isn't it? Distance d, we got 2r minus r. This is basically r. So the answer becomes C. All right. So guys, these are some of the questions you just have to work out a lot of things so that you can get to the answer. You cannot just skim and scan or do the things that like crazy. Anyway, so for it to be a quarter, I mean, some people are smart. They can just look at ratios and proportion and say, well, if this is a quarter, it means we have doubled the distance, essentially. So that should be just r as well. But let's not go there at times just to do the calculation to be convinced. But others are that quick, they don't even need a calculation. But those are questions to watch out for. Now 1.3 says, a girl standing on a lift observes a 10 Newton mass piece, okay, suspended from a spring balance that is fixed to the roof of the lift. Okay, so we've got a lift here, right? And then we've got this mass piece here that is fixed to that roof. Okay, great. And then of course it hangs something. So it's a bit complicated, and then of course there would be the numbers there that are telling you exactly what is the measurement of this weight. Okay, so what is the story here? She sees that the reading on the spring balance is greater than 10 newtons for a short time interval. During this time interval, the lift is it not moving? When it's not moving, it should read 10. So for it to read more than 10, it means it is definitely moving. So that question of not moving is not quite. And then, is it moving at a constant velocity? Remember, constant velocity, there's no external forces, everything is balanced. So it should read 10. It would be the same as it would be the case when it is not moving. So no, it can't be. Remember, when it happens for a brief moment, it means there was a bit of an upset. Is it accelerating upwards? Yeah, most likely. Because as this is going to be upward, because of inertia, this body will try to refuse to move. It will attempt to stand there. As it does that, then there will be a pull on the string balance, on the spring balance, and then the reading will be a little bit greater than 10 newtons until the balance is attained. Once this starts accelerating at the same acceleration as the lift, then the spring balance will go back to 10 newtons. So that is the most likely answer. Is it accelerating downwards? No. Remember, when it is accelerating downwards, what would happen is this would attempt to stand there while the lift is going down. So there would be a little bit of a moment when there is no tension on that spring balance, so much that the reading will be instantaneously less than 10 and then catch up. Okay, so this one can't be true. So the answer is C. All right, so always picture these things and think about them a little bit more deeply than a superficial look. Okay, a ball of mass m hits a wall with a speed v. Okay, so we've got the wall here, and there's our ball of mass m, and it's going in that direction, speed v, and then it's going to hit this portion of the wall. Okay, and then rebounds in a straight line. So the ball now is on the way back after hitting there. Now this is still mass m, and then in the straight line in the opposite direction with the same speed. Okay, so this means we still have v, but now if we choose to the right as positive, to the left is going to be negative, isn't it? Okay, maybe let's use the luxury of colors. Okay, so that is the case. Now what can we do? We're asked here the magnitude of the change in momentum of the ball. So we know that the change in momentum of an object is going to be mass, taking the final velocity, subtracting the initial velocity. The mass was m, the final velocity was minus v. minus the initial velocity, which was v. This is going to be m into minus 2v, which is minus 2mv, and essentially 2mv in opposite direction, right? Or you can say west, or you can just put an arrow. Okay, there's a lot of things you can do, because remember the negative direction was to the west or to the left. All right, so now what is the answer to that? It is B. We are only asked about the magnitude, so the direction was not asked. So if the direction was asked, then we would be able to handle that. So the answer becomes B. Okay, now let's look at 1.5. A ball is thrown vertically upwards. So there's our ball, and then it will reach maximum height over there, and then come back down to the same position, or even go beyond that position. Now I told you, which one of the following physical quantities has a non-zero value the instant the ball changes direction? So meaning at this instance it is non-zero. So we know here no one talked about ignoring effects of air friction whatsoever. So we know that, okay, as this object is going up, there's two forces acting on it. No, they're not acting that way. So there's going to be gravitational force downward, and there's going to be air friction depending on what is the magnitude of each. Then there's going to be air friction, let's just say AF whatever, or let's just say FA. So let's just say friction by the air. Okay, so as it goes up, we know that of course the time it will take to reach that maximum height right there is going to be much shorter than the time it will take to come back down, because as it comes back down after changing direction, the air friction is going to be exerting a force upward, and then the weight is going to be exerting a force downward. And then there will be a point somewhere just before it gets to the ground. We don't know what that point is, when air friction is definitely going to be equal to Fg. Okay, this is when it is doing a situation called terminal velocity. Okay, and it is essentially a constant velocity. So there will be a lot of things going on when it is coming down than when it is going up. And then this is why we know that if we say this portion here is T1, and then this portion here is T2, we know that T1 is less than T2 for the fact that we did not create a vacuum, okay, where only gravitational forces acting. And of course at first it will be accelerating down, but it will reach a point when the air friction catches up with the magnitude of the gravitational force, such that these two are now perfectly balanced before it comes to the ground. And then as it will be descending to the ground, it will be doing a constant velocity. So these are some of the things to think about, but I mean, they're not that important. So anyway, is it acceleration? The answer is yes, because we still have a resultant force even at the maximum height, because these two forces are acting down even there. And then even past that point, there's forces acting, there's a resultant force, until a time when it will be doing the so-called terminal velocity, which is essentially a constant velocity, when now the air friction is balanced by the gravitational force. So essentially the acceleration at this point is non-zero. But at this point, if they were to pick this moment right here, when we are saying it is doing constant velocity, it will no longer be accelerating, okay? It accelerates up to a certain point, and then that's what happens. Of course, considering that would be the case if we were not to ignore a friction, but if we do, then we just accelerate all the way down. So acceleration is true, it is non-zero. Kinetic energy is definitely zero. Why? Because the velocity at the maximum height is zero. So since kinetic energy has something to do with velocity, then that product essentially becomes zero. Momentum is definitely zero. Why? Because it's also related to velocity. As you know, P is equal to mv. Here we know that EK is equal to half mv squared. Okay, remember those formulae. The velocity is unfortunately zero, so the answer becomes A. I'm sorry guys for the mixed masala of colors there. I'm just enjoying the things, you know. Now the molecular formula of an organic compound is C4H10O. And then of course, you know, once you see only a single O in an organic molecule, you are either looking at an alcohol or you're looking at an aldehyde or you're looking at a ketone. Okay, so these are the most likely ones to be the situation right here. Now, which one of the following is the functional group? Ooh, that is great. Which one of the following is the functional group of organic compounds? Okay, so is it a formal group? True, because this is the carbonyl group at the end of a chain or beginning of the chain. This is the carbonyl group at end or start of chain. Okay, the hydroxyl group, it could be because we're saying it's an alcohol. That is for alcohols, of course, primary alcohols or any other alcohol, it doesn't really matter. This is just for alcohols. And then is it a carboxyl group? Carboxyl group, remember, it is COOH. So the oxygens, you should see an O2 at least. Okay, so now we don't have an O2, we just have a single oxygen, so it can't be a carboxyl group. Could it be a carbonyl group? Yes, because we said a formyl group or carbonyl group is one and the same thing. It's just a difference in the position in the chain of that carbonyl group. So the answer is between the three now. So oops, we have a problem. Now let's have a look at this molecule right here. C4H10O. Okay, let's just write the O like that. Now what do we do with this, guys? We always look if this friend here, this portion here, matches the general formula of alkanes. Let's say it matches CnH2n plus 2. If this guy matches that, then we know we are dealing with an alcohol. Okay, of course you add the oxygen. If that is the case, that is true. So now let's go for it. It's C4. Cn is 4 though, so we've got C4. 2 times 4 is 8 plus 2 is 10. So definitely this matches the general formula of alkanes plus an oxygen. So definitely this is an alcohol, and therefore the functional group here becomes the hydroxyl group. Okay, if that matches, we are happy. So this is described by what we've just done. So the answer is B. Okay, so we're dealing with an alcohol. Now let's look, if this was a carbonyl group, we know that this portion should match CnH2n plus O. I don't know if we write a plus like that or what. So now, as you can see here, no, we have 2 extra hydrogens because this would have been C4H8O. And again, it's very difficult on a molecular formula to differentiate between a carbonyl, from a ketone or a formyl group. In fact, if this was the case, you could pick any one of the two. But it's no longer the case, which makes our lives a lot easier, so we can escape the problems. So you have to do something, guys. Always be in a position to look at these things. Of course, some textbooks are very nice. They show you this general formula of each of these organic compounds, but some textbooks do not. So you have to be able to know the structure well, to know exactly what does it resemble. Okay, this one resembles alkenes with an oxygen, because you're losing 2 hydrogens there from that double bond, whereas in alcohols you lose at least 1 hydrogen. Okay, and therefore it behaves like alkanes in a way, because you still make it back from the OH, isn't it? So yes, okay guys, let's not overly explain, let's just keep moving. Now a functional isomer of ethyl propanoate. So now ethyl propanoate is what? Is an ester. Okay, now let's look in this. So now what is ethyl propanoate? It helps sometimes to just draw the structure. Ethyl, it means there's 2 carbons. And then of course, if this is an ester, it's going to link with an oxygen to the carbon that bears that double bond oxygen on the other side. So we said propanoate, so it's going to be 3 carbons here, including the carbon that bears the double bond oxygen. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 hydrogens here. So now let's look. It says now the functional isomer. Remember, functional isomer should be a carboxylic acid. Okay, so anything that says COOH is a friend of ours that we are looking for, depending on what is it. So this already is telling us these are aldehydes, because that CHO at the end of the chain is already saying these are aldehydes, so you don't want to think about them. So that is aldehyde. So now these are the 2 carboxylic acids that we need to try and match with this. Of course, now we need to think about it. What would be the molecular formula here? This is going to be C1, 2, 3, 4, 5. So C5H2, H how many? 3, 5, 7, 10. So H10, okay? And then O2. But in any case, we don't really care here, because they decided here to leave the COOH part. So if we sort it out, it becomes, now this is going to be C4. It's no longer going to be C5, because the other C goes there. So it becomes C5. Now this is no longer going to be H10. It's going to be H9 COOH, right? So that is what is happening, because the hydrogens are 10, the carbons were 5, so this is not going to be C5 still, it's going to be C4, sorry. Yeah. And then yeah, C4H9 wara. Otherwise this makes life a lot easier. So if we're looking at what we want something like that, and then this is the one. So the answer here is C. So that would be a functional isomer, because it has to match. There has to be 5 carbons. In this one there's 4 plus 1, which is 5, okay? Then there's hydrogens, there's 9 plus 1, which is 10. And then there's 2 oxygens. So yes, C is the best answer. All right, so let's keep moving. So if we keep moving, we're told now which one of the following is the empirical formula of 2-methyl pentane. Again, it helps to look at the structure and say what is 2-methyl. It's 1, 2, 3, 4, 5, and then on the second carbon we've got a methyl group, and then we've got hydrogens. Okay, so basically this is C6. 1, 2, 3, 4, 5, 6. So we've got C6H 3, 6, 7, 9, 11, 14. So that is the molecular formula that we can make up. And then now we want to look at the empirical formula. Empirical formula, we always look at the smallest value. Can 14 divide 6? No. Now we go to the next one. Can 6 divide 3? Yes, but 14 cannot divide 3. Can 6 divide 2? Yes. So we divide by 2. 14 can divide by 2. So we get C3H7. So that is the guy we're looking for. So that is the empirical formula. Remember, the empirical formula is the simplest molar ratio of atoms in a molecule. Okay. So you always need to know how to do these things. You've been introduced to these empirical formulae in grade 10 already. Grade 11, you've worked through the same thing. Grade 12, it comes as a surprise every now and then. Okay. So you see the steps. You need to start here, move here, and then down there to get the answer. So it's an indirect question, so don't underestimate the difficulty it can present for you. Which one of the following represents a product of the thermal cracking of butane? So butane is 1, 2, 3, 4, and then hydrogens, okay? Now, what do we see with cracking? We can split here. Okay, if we split here, we can have methane if we want, and then if we've got methane in there, that means we're pulling one hydrogen, so we may end up with methane and a propene. Okay, because this is what is going to end up happening there. When we lose one hydrogen, we'll be forming a double bond. Trying to think now, is it a propene really? Yeah, we go home with that. So we will need another hydrogen. Where will it come from then? Anyway, this is stuff like this, guys. What can I do? I've got to do something, man. Then this one is one hydrogen. So we'll end up with something like that. Let's see if this hydrogens balance. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, our hydrogens balance. So I don't know what exactly did I miss somewhere, somehow. It's not a big deal. So that hydrogen will come here where the double bond forms. Great. So that means we can get CH4 or C3H. How many? 3, 4, 6. Okay, we're looking for something like that. Do we have anything like that? No. We don't have C3, we don't have C2. So this possibility is squashed. So let's look. If we split here, what do we get? We can get an ethane, and we can get an ethene. Okay, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it still balances. So we're looking at C2H6. Okay, C2H4. Great. So it says now, which one of the following represents a product of the thermal cracking of butane? Well, can we get C2H2? The answer is no. That one is not possible. As we can see that there's no C2H2 here. And then C2H4, yes, we have it. C4H6, there's no C4. We can't still have a C4 if we're cutting a C4 into pieces. So anything that starts with a C4 is already eliminated. So the challenge was between these two. So this one takes the crown because it could easily be what? Be this ethene. This is ethane. Okay. So this one says yes. We are good. So again, these are indirect questions. You can't just sniff an answer. You've got to work it out. Okay. You've got to work it out. So this one didn't work. Of course, you are guided by the options because remember, you cannot further crack it here. Because if you crack it here, it would be the same as cracking it the first instance. Okay. So there are only two ways we can crack it. It's either there or there and nowhere else. Because it pretty much repeats the cycle. Okay. Whew. Last question. Consider the structural formula of an organic compound given below. Now, you already know that once you see this, guys, you're looking at an ester. Okay. Ester lona, ester eBhayibhelini ke ester. Jwale ha re shebile ester mona re tlo qala jwang? Re qala ka nqena man. Hlakorong lena o tlo sheba this hydrophobic end, okay, which is facing the single oxygen. So this already gives us the alkyl part. Okay, an alkyl is an alkane that has lost a hydrogen. Okay, great. And then we're going to look at the carboxylic acid part, or the so-called carboxylate ion. This is this part together with the hydrophobic end. Okay, so that's how we look at it. And then of course probably it's going to be a question of the IUPAC name. Okay, now it says this compound is the product of the reaction. Oh, okay. So they're not asking the name, but they want us to tell. So we can see that this is 2 carbons. So this is ethyl. The alkyl part is ethyl, meaning it came from ethanol. Okay? Ethanol or ethane 1-ol, because this is a primary alcohol. And then this other end, which carries that head, the polar head, is the carboxylate ion. Carboxylate ion, or carboxylate group, or whatever, carboxylate ion. Okay, the carboxylate ion, sometimes you can say it's an alkyl alkanoate. It's an alkanoate ion, or carboxylate ion, or alkanoate ion. Now this one is how many carbons? 1, 2, 3, including the one that is born on the functional group. It's the propanoic acid. Propanoic acid. So basically it was propanoic acid and ethanol. So let's look for that. Ethanol, ethanoic acid, hell no. Propanol, propanoic acid, hell no. Ethanol and propanoic acid, yes. So the answer here is A. So these ones are correct. So please guys, again, these are questions that are easy, but at times they can be confusing. All right, let me just go drink some water. Let's just take a... Okay guys, I am back. Yeah, I'm really tired. Today was a long day at work, so just trying to rush through this thing quickly. Anyway, let's have a look at this one. It says now, a force of magnitude F. Don't know why I have now left my highlighters, and yet they do a better job than this circling business. Is applied at an angle theta. Okay, with the horizontal to a box of mass 60 kilograms. So we've got our mass right there, placed on the floor. Okay, there's the diagram, we can already see it. With force F applied, the magnitude of the maximum static frictional force. Now remember, once we say static frictional force, it means this system is not moving, it's at rest. Okay, between the floor and the box is 140 newtons. Then of course, if we're looking at this one, we know that the friction would be going in this direction, right? This is static friction of 140 newtons to the right, because this force would attempt to move this block through its horizontal component to the left. But frictional force is saying, hell no, you have to overcome me first before you can do that. Okay, I'm not letting go. Anyway, so we can see that it is neither going into the ground nor being lifted off the ground. So these things need to really be clear on your head. So guys, we've been doing a lot of these Newton's laws of motion. So if you're still shaky here, then it means you guys are not really serious, eh? You can only be confused by some challenges, but I think we've been dealing with these questions a lot before this exam, so I don't expect any one of you to fail this question. If you do, please raise your hand so that I can come for you and hang you by your shoelaces, so that by the time you're trying to die, that thing will have snapped, but you'll have felt the difficulty, right? So really, these questions should not be eating a matriculant at all, not after what I have done with you guys, especially those who have subscribed to the channel. You have no excuse here. I've taught you every trick I know works, and you should, at least by now, having been ready. Okay, so in any case, that is what we have. So if we break this force into its components, we know for a fact that, okay, there's going to be that vertical component of that force, which we can call Fy. Then there's going to be the horizontal component, which we can call Fx, and these two are perpendicular. Okay, great. So these are the components of that force. Sometimes they are called perpendicular components, you know the things, but I mean, I'll always drip extras as we go along, because now I'm more comfortable. I've done most of the groundwork, so I can now spice it up a bit every now and then. So if you are asked what are the perpendicular components of that force, it is basically these, or just simply components of that force. Just know they are always perpendicular with each other. So okay, so there's how many forces in the vertical direction? There's 3. Fg, opposed by the addition of the normal force and the perpendicular component of that force. The horizontal force is acting as the horizontal component of that force and the frictional force. Okay, great. So now I told you the coefficient of static friction between the box and the floor is 0.3. So that is the coefficient of static friction. Okay, great, so not a problem. And then it says the applied force does not cause the box to lift off the floor. Okay, that is additional information, because that is exactly what is happening. So this is trying to suggest that the forces acting perpendicular to the horizontal are essentially not moving this object in any of the vertical directions, meaning up or down. Okay, so it would either move left or right, but again, we were told that we're dealing with the maximum frictional force here while this force is being applied. So this means this box is at rest. If it is at rest, it means all these forces are balanced, and that means the system is in equilibrium. Okay, don't know what was that at the end right there. So the system is in equilibrium. Great. So that's what we can get from this. Okay, now let's start attacking the questions. So 2.1, we're told to define the normal force. So how do you define normal force, you guys? So you guys must be telling me things, okay? I want to know, what is the normal force? Okay, so basically it is the force exerted by the surface on an object that is in contact with it. Meaning the object is in contact with the surface, right? It is, let's just read again. It is the force exerted by the surface on an object that is in contact with it, such that the force is acting perpendicular to the surface. Can I say that? Because that perpendicular part has to come out, okay? So we can say that this force, such that the force is acting perpendicular, this force, maybe like, let's say such that this force, what can I say? I'm trying to figure out now. Okay, such that the force always, maybe let's say that, because this word is important, it always acts perpendicular. Perpendicular to the surface, right? Okay. On which, yeah, on which the object is resting on, okay? So you want to be comprehensive because there are certain key elements here. This part has to come out. I don't know, you guys are smarter, you speak English better. I mean, we beat our tongue through university and we're still doing it, but you guys are flowing, you're smooth. So you find the words to put this nicely, but make sure the perpendicular comes out, okay? And exactly that, this is the force that is exerted by the surface on an object that is in contact with it. And this force has to come out that it is always perpendicular to the surface that or on which the object rests on, okay? So please find the language. It does not matter to me. That's why you need to learn English, so that you can be able to formulate your arguments. Don't be a cramist. I hate students who cram, and anyone who advocates for that is no friend of mine or is no, should I say, fan. I'm not a fan of so guys, don't cram. I beg you, do not cram, do not cram, do not cram, do not cram, and please don't regurgitate. It's a disease, you know, to regurgitate the food that you've eaten. You have to grind it, you have to digest it, you have to assimilate it. It has to, you know, build you up somehow, so that everything that has to do with anything related to these concepts, it is second nature, okay? Cannot overly emphasize the fact that most of these things have to be second nature. You cannot still be digging for these in the ground, okay? These are things that you should just be grabbing to use whenever you need them, all right? Anyway, let's not talk too much. So that is how you get your 2 marks. Easy 2 marks, nothing major. Next question says, oh, I'm already on point 3. Yes. Yeah, I'm not really myself, guys. I'm a bit beat up by the day's work, but yeah, we're going to do it. Draw the free body diagram showing all forces acting on the box. So we can already see that here we've got how many forces is that? Applied force, it is the gravitational force, it is the normal force, and the frictional force. These components essentially give us that force, so we don't worry about them. So if we draw our free body diagram, we will have that guy over there. That is the force, and then if you like, you can show this theta. It's not a big deal. And then we're going to have a horizontal force to the left, which is going to be the static friction. And then we're going to have a force perpendicularly down. Do the things that can be done. Don't irritate me. You don't want me angry, eh? I'm a nightmare when I'm angry, am I not? I like to think so. I'm not the nicest person when I'm not happy. But I try to contain myself because you know what, it's not about me. Because others are bulls when they are angry. I may just be angry and not be a bull. Yeah, but you'll try me though. Yeah, you'll see something. Okay, you're getting those 4 marks of words. You can break this force into its perpendicular components. That means you eliminate that force when you do that, and both of them are only going to count 1 mark because they effectively lead us to one resultant force, which is that force F. So you may as well just represent the resultant of them instead. Great, so that's how you get the 4 marks, guys. Let's just keep going. Now it says calculate the magnitude of the normal force when the static frictional force is at its maximum. All right, so you can see 3 marks. Easy question. Don't even think too hard there. 2.3. We know that the frictional force is given by the coefficient of static friction multiplied by the normal force, which implies we're given that this is 140 equals, this is 0.3 times n. We know that therefore our n is going to be 140 divided by 0.3. Here's my calculator. So 140 divided by 0.3. This is 466.67 newtons. And then it's upward. I know I always treat vectors with respect because there are questions that will hit you when you least expect them. In fact, you will overlook the fact that they did not specifically specify the magnitude, and then you lose marks on the direction. So just always do it. You're not going to lose a mark for doing it, but you're also not going to get an extra mark for doing it when it is not necessary, okay? So you're getting a formula, correct substitution, the answer. Easy, 3 marks. Let's finish this thing now. Determine the angle theta. Get 4 marks. So 4 marks, don't always think it's easy. It's never easy. So I'm warning you, when a question is 4 marks, be very careful. Yes, there may be an easy way, but not always. Most likely, you're going to be dealing with a bit of a complicated situation. So this is what? 2.4. I don't know why I left so much space, or I did not. Okay, now 2.4, guys, we need to find theta. Now the problem is we need a few things to be sorted. First of all, we need to think about theta in terms of this triangle right there. It is a right angled triangle, and then we know that the fx was directed that way, and then we've got theta over there, and then we've got our perpendicular component, or should we say vertical? Maybe I always say perpendicular, but it's actually a vertical component. Sorry for the wrong, you know, sometimes we have our own errors. So this is actually the vertical component, horizontal, vertical. These together are perpendicular components of that force. Yeah, man. Let's refine that. Okay, so this is the picture you guys need to think about. So I'm going to put it in a box because this is stuff to consider. Now there's a second picture that we need. We need this picture here. We know that the frictional force is doing its thing in that direction, and it is 140 newtons. But since we are moving, we know that our Fx is perfectly balancing the frictional force, because we're neither moving to the left or to the right, okay? Because if the static friction, it means the object is not moving. Okay, it's just about to move if we apply a force greater than the maximum static friction. So we need to think about this guy. And at the same time, we need to think about this guy too. This guy is like that, Fg. And we've got, I don't know which one is bigger than the other. So guys, don't kill me for this one. If I made them disproportionately whatever, I'm not interested. So I would say this is the normal force. This would be the Fy, which is the vertical component of that force. So we need to think about these three diagrams, so to speak. Because for us to get theta, we need a value on Fy. And Fy can be found here. We also need a value on Fx, and Fx can be found there. Okay, so these are some of the things that we need, because we're just going to keep it simple now. First of all, I'm going to say, considering the horizontal components, I know that, well, Fx plus Fs is equal to 0, isn't it? Yeah. That is the story. That is the story. I mean, guys, okay, let's do it properly. Sometimes I know I'm too quick. So let's say the resultant force. Now let's just say horizontal movement. So we're considering horizontal movement. Let's just say horizontal section, because it's not really moving, is it? So horizontal section, it is such that the resultant force is equal to ma, which implies that Fx minus 140. I'm just going to substitute straight up, guys. It's a waste of time to do anything else. This is going to be what? What was the mass of this object? I kind of forgot. It's 60 kgs. Okay. And there's no acceleration, so it's 0, like that. So I'm just doing this for the sake of trying to be complete, guys. Otherwise, I would not have done it. So Fx is going to be essentially 140 newtons. And in which direction? Westwards. Okay. You would see that it is the opposite direction to the other one. Not a problem. So we know now we have 140 here as well, newtons. So our triangle is starting to fill up. We can say vertical position or vertical section. Vertical section. What is happening in the vertical section? We also know that the resultant force is equal to ma, which implies that Fy plus the normal force is going to be, don't do that, minus the gravitational force is going to be equal to ma. Not a problem. This implies that Fy plus, we got this one, 466,67 minus 60 into 9,8 is 60 into 0. I'm not going to prolong this calculation. You guys already know how to do algebraic calculations. I am certainly not interested. So this one is 466.67 minus 60 into 9.8. So this one gives us 121.33 newtons. Okay, easy. And then this one is upward, is it not? Yes. Again, now the puzzle is 121.33 newtons. So do you see our triangle is complete? So what can we say now? We can say then tan theta is going to be Fy over Fx, is it not? Yeah. Which is going to be 121.33 divided by 140. Okay, we can say therefore theta is going to be the inverse of this ratio, 121.33 over 140. Ne? Yeah. Hey guys, I'm relaxed. Ne? I was supposed to have finished this question before I got to an hour. Ne? So shift 10 of this ratio, 121.33 divided by 140 is the things that can be done. So I'm getting 40.91 degrees. Okay, so that is the answer. Okay guys, you can think of any other way that suits your taste. I was essentially running into problems a bit. My space here was not well determined. Okay, so this is 40.91 degrees. So you can see here, to answer this question, it looks simple, but maybe I chose the longest approach. But sometimes you've got to have things in your mind that assist you to work. Okay, so please Bafua, to do the right thing. Always make sure you have an interpretation of all the stuff that you are given. And then of course, when you are so comfortable, you may even escape using these formulae because they no longer serve the purpose anyway. If you know that things are balanced, you can just say this is equal to that. The system is in equilibrium. Done. On the horizontal, there's no other force it can balance with except the static friction. But now on the vertical ones, you may have to show a bit of a calculation of some kind, But yeah, you graduate, man, you graduate. So it was important to show that this force is that one, and to show that this force is that one, and to show that this force is this one. And then of course, to be able to do our tan theta. I'm not too sure where, guys. Maybe we can say substitution, perhaps. It's a very difficult one to give the 4 marks. Anyway, let's not waste time. Let's just move. Now, question 3 says a ball of mass 0.5 kg. So now we're going to move, guys. Is projected vertically downwards. Sure. Okay. Now, this one is not projected upward as usual, okay? From a height of 1.8 meters with an initial velocity of 2 meters per second. So remember, this is a projectile. As soon as it has an initial velocity, it is a projectile, right? Now the ball hits the ground and bounces 2 times. Okay? Now the position time graph for the motion of the ball from the instant it is projected until it hits the ground after the second bounce is shown below. Of course, our famous statement, ignore the effects of air friction. If that is the case, it means the only acceleration we accept is g. So the acceleration there is g because we only have gravitational force acting. Now let's look at this one. You can see that this object went to that height, spent some time, and then started, changing position and then back again. So we should assume that technically this is the ground. Okay, it's not even to say we're assuming that is the ground. And then this position should essentially be the ground too. Okay? Yeah, spare that my ground looks horrible. I'm just trying to avoid touching this screen. It really works on my nerves. Okay, so this is going to be maximum height number 1, maximum height number 2, maximum height number 3, right? This is when the direction changes. Okay, so this is the time spent in contact with the ground, which is the impulse time. Okay, great. So now if this is doing that downward movement is positive, it means the graph from this scenario downward was taken as positive. So unfortunately, this is now something that the diagram dictates. You are not dictating for yourself. It unfortunately chose the issues for you, so you just have to deal with it. Now write down the maximum vertical height. So it says write down the maximum vertical height reached by the ball after the second bounce. Okay, remember this was downward to the ground. It spent that time, it bounced up, reached maximum height and hit the ground the second time, and then it bounced up the second time. So it basically means we are looking for this part here, because as you can see, this height corresponds with that height over there from the ground. Okay, so basically it is the difference between 1.8 and 1.3. That's what it is. So now you're just going to do that difference. Of course, I'm going to answer this one by showing you how I did it. So we can say the maximum height is going to be equal to 1,8 minus 1,3. Okay, I simple. Scan try 1,8 minus 1,3, so I'm getting a 0,5 meters. Okay, of course you don't have to show the calculation because they just said write down the value, so you show up with this one, you're okay. If you show the calculation, no one is going to penalize you anyway, but you just gave yourself an unnecessary amount of work. They didn't care how you got it, but I'm just showing you. Okay, so you could easily just write 0,5 meters. So you just read it as that difference between that 1.8 and the 1.3, because that's from the ground up. Okay, although it is, put in a very awkward position. Okay, 3.2 says the ball strikes the ground with a speed of 2 meters per second and is in contact with the ground for 0,2 seconds during the first bounce. Okay, great. So it means that this time frame right here is 0,2 seconds. Okay, that period from T1 to T2, because that is the time in contact with the ground. Okay, not a problem. So what does this tell us? It says calculate the time T1 as indicated on the graph. Okay, so we just want T1. Okay, how do we get T1? So we've got two options. We have the height. We know the maximum height. Okay, we know that the maximum height there is basically 1,8. We know the initial velocity. We want the time. So there's a formula that has only that, but I don't like that formula. It's complicated. I'll show you why. The one I like is this one, because we're doing a free fall anyway. The one I like is this one of the final velocity equals the initial velocity plus g, because that's a free fall we're doing, delta t. That one is much better, because we've been given the final velocity that this is 6,27 is equal to the initial. We were given that it is 2, and they were all directed down, so they are positive, plus 9,8 delta t. Even 9,8 is positive because this graph says downward is positive, so everything is positive here. Therefore delta t is going to be 6,27. You transpose the 2, you divide by 9,8. Always attempt to simplify your business so that it becomes easy to handle. 6,27 minus 2 divide by 9,8. I'm getting a 0,44 seconds. Remember, we're told a minimum of 2 decimal places, so we can round off to 2. You can leave out more. It's up to you. So here we're getting a mark for the formula, correct substitution, and the answer. But now they were giving 4 marks here. A thing that does not make sense. Maybe we can say therefore T1. Yeah, because that's what we want. Of course, I am not too sure what is the story, but I think you get an extra mark for all the positive values here in the substitution. I have no idea, honestly. Where is the second mark coming? But let's say you just chose this one. Delta y is equal to the initial velocity delta t plus half g delta t squared. Okay, how would you handle this? You know that this height, remember, the height is downward, so we're moving downward, so this is going to be positive 1,8 equals the initial velocity is positive 2 because it's directed downward, delta t, plus now we're going to have 0,5 into 9,8 delta t squared. Okay, everything is positive, and then this would imply, of course, remember this is a different scenario. Okay, maybe we'll separate it later. This implies that we've got, now this is 4,9 delta t squared plus 2 delta t. Transpose that, it becomes minus 1,8 equal to 0. I've just rearranged as well. Then you'd be forced to do the quadratic here. That's why this one is complicated. Maybe that's why they're giving 4 marks, because they probably thought about you would have to do this minus into 2. I remember here you don't have to write the formula again. You can just substitute within the formula. Okay, so you will see that the answer here that we get, let's see, minus into 2. I'm just really wasting time, guys. I don't know why, actually, because you know what? This is ridiculous. It's as if you guys don't know, but I'm just trying to be a bit complete, you know, so that you guys don't say, ish, yeah, these things, they are doing the things. Now I'm getting 0,44 to 2 decimal places, or T1. Okay, we can say therefore T1 is that, or T1 is equal to. Now let's see when we put a negative in there, what happens. But obviously, if this is negative, this is going to be negative. The numerator becomes negative. This one is going to give a negative answer, which time cannot be negative, right? Because if you do your planning properly, once you get a negative, you know that this is minus 0,84. And T1 cannot be a negative number, so you would still choose that. So I guess The extra mark is rejecting something, okay, and accepting something. That's my feeling. That's just my feeling. Maybe this is why they said 4 marks, because they probably thought about it in this way only. But you could actually do it in a much easier and shorter way without struggling. No problem, guys. So let's just keep moving. I am really chowing our time here. Now determine the velocity with which the ball leaves the ground after the first bounce. Now that is something else. Okay, this is 3,2,1. Okay, this is 3.2.2. Now we want the velocity with which the ball leaves the ground after the first bounce. Now let's look at this one. Now we have a few issues. We know that the velocity here is 0 because that's the maximum height. And then we need to know what is this height. This height is essentially this one right here, which is 1,8 minus 0,9. That gives us our delta y. Okay, if we've got the height, we've got the final velocity, and we're looking for the initial velocity, our lives are sorted because we don't have to stress and be looking for things that, you know, are not necessary. So let's just do this one. This formula makes life easy. The final velocity squared equals initial velocity squared plus 2g delta y, because we don't want anything that has time there, because we don't know what that time, in fact we do, but yeah, leave it alone. The time to the maximum height, the new maximum, we don't know, so we're going to keep it to this one. This implies at the maximum height we know that this is going to be 0. The initial velocity squared is what we want, plus 2 into 9,8. We chose downward as positive. But now this one, this motion here, if one looks at this segment is actually upward. So if it is upward, it is a negative motion. So this height is going to be minus. Oh, that's going to be minus. Now let's do the difference, because basically it is the difference between, I'm trying to think now. This is going to be, look, we can actually play it smart and not even include a negative sign. We just play it smart. We just know that this is going to be 0,9 minus 1,8, isn't it? We start with the last, take the initial. Life is easy. Everything is sorted. This implies, now we've got V1 squared, Vi squared equals, now remember this whole thing is going to be negative because 0,9 minus 1,8 is basically a minus 0,9. So minus 0,9 times 9,8 times 2 gives us an answer of minus 17,64. So when you transpose it becomes 17,64. Okay, so guys, I'm just moving a bit quicker when I can. Therefore, the initial velocity here, this is now leaving the ground upward, so it should be the negative version. We can say it's gonna be minus. Now, the square root of 17,64. Remember, that would have been a plus or minus, so it's going to be 4,20 meters per second, which is 4,20 meters per second. Now this one is upward because upward is negative since we chose downward as positive. Okay, so that is the best way to go about it, I believe. Makes life a lot easy. And of course, formula. This calculation is an extra calculation, by the way, and then the general substitution. and the answer, but the answer will have to include direction because we were not told to the magnitude. So do you see, making it a habit to always include direction in your calculation of a vector quantity. Here, if you don't have this issue here, you're not gonna get a full mark, you get half a mark. That's the story. Now calculate the magnitude of the force exerted by the ground on the ball during the first bounce. Easy stuff. 3.2.3. This is the impulse stuff. So even though you're not in the momentum section, in grade 12 you integrate, so you can't complain and say, no, but we're not yet on the momentum question. It does not matter. This implies now we want the force, the time is 0,3, 0,2. The change in momentum is going to be the mass of this object, which is 60, into the final velocity, it's minus 4,20. Remember that was negative because it's directed upward. So when you substitute it, the sign must come back. You're minusing the initial velocity, which was 4. No. Maya. The initial is the one that it hit the ground with, which is 6,27. So therefore the force is going to be, let me just help you out, 60 into minus 4,20 minus 6,27 all divided by 0,2. Otherwise I should not be showing you that gymnastic, but it's important for you to portray it, because should you find an answer that doesn't make sense, it helps you a lot to tracking what happened, where did you make the mistake. But when you are confident, what can I do? What can I do? Wait a minute. What? Hey, I put 60 and niyandiyeka nina niyakula kanjani? Nithulile ntoni? Yini ukudiyeka denze mistake engaka? This is 0,5. Remember the mass of this object is 0,5 kgs. Nina niyathula nje, ndinidlisa poison. Aninandaba. Qhaba ni. 0,5 into minus 4,20 minus 6,27 divided by 0,2. Now what do we get? We're getting minus 26,18 newtons. But now this means it's 26,18 newtons. If it is negative, what does that mean? This force is directed upward, which makes sense, right? Because it changed the direction of this object of ours. Great. So guys, this is how easy this thing is. Formula, substitution. Now what did they say? Magnitude. Yeah, it said magnitude, so they didn't want the direction, so we can put it in brackets. But even if you did not, no one is going to give you a hard time. So this is the answer. Then it should have been 3 marks, you know. These guys, they are surprising, you know, how they, yeah, doch. Anyway, we can just grant you an extra mark on this calculation here. It's fine. But it's not really worth 4 marks then if the direction is not to be considered. Hey, but these people, they like to spoil the party, ne? Just don't like peace. They want me to complain all the time. Why must I complain, man? Can't you just let things be smooth, people? Okay, enough. Now it says draw a velocity time graph for the motion of the ball from the time that it is projected. Okay, time that it is projected to the time it rebounds to the height of 0,9 meters. Okay, now where is that? Where is that? 0,9, 0,9, 0,9. 0,9 is this one, is this second bounce right here. So basically we just want the first bounce only to the maximum height. Therefore, so we don't want extras. All right, okay, all right. We are going to do it like this. Of course, guys, you must have a what is this, by the way? It's a velocity time graph. So VT graph of ball. Is it a ball or was it? Yeah, they said it's a ball. So this is the velocity time graph of the ball. A heading must always appear. If it does not, marks deductions will surprise you. Okay, so if you don't want surprises, make sure things are done. So here we've got time in seconds, and then we've got velocity in meters per second. This is 0. And then of course we projected this thing at 2 meters per second, so we chose downward as positive, so that was 2. And then it reached a maximum velocity of 6,27 to hit the ground. And then now what happened? From 2 to that velocity, it took how long? It took 0,44 seconds. That is the time we calculated. And then we can do the graph and say, there you are. There you are. So if we do this thing like this, I don't know. So it is like so. Okay, so we started there and we went there. Okay, don't worry, we'll sort out everything else later. And then we spent some time on the ground for like a moment in time here. If we say that period is 0,2, so it's 0,44 plus 0,2, it gives us 0,64 seconds. That is when it started bouncing off. So this one we can make it here. I mean, it's not really drawn to scale, minus 4,20, ne? Yeah. Okay, now khona nowenzekayo apha. Okay, minus 4,20. And then if I can just try to approximate where that thing is. This thing is right here, perhaps. Actually here. Eh? No, man. Here. Yeah, it's right there. Okay, so messenger in right hand. There is a bit of a mess now. We see that we have this one. Yo guys, this thing is chewing my time now. I'm not happy, you know. I am not happy, okay? So you guys know that this is 0,64, ne? Yeah. And we will take it from here. So this is when it bounced off from the ground back to this maximum height. We don't know what time it took to get there, but all we know is that it does this thing here. And then of course, if you are very accurate, you can see I tried. Because the gradients are the same, these lines should be parallel, okay? Those lines should be parallel if this thing is to be done properly, okay? Of course, I'm just adding the parallelity so that you can see, but you don't have to include it. But remember, they have to be. Okay, now we can do our gymnastics on our things there. We don't want this one. Okay, so you see, we've done it. And then we were not asked the time at which it reached the maximum height. So we're not interested, okay? They just said the velocity the ball it rebounds off the ground. This is the velocity right here. and then the velocity of the ball when it hits the ground, that is the one over there. The time when the ball hits the ground, that is the one. So they did not ask about the time at which it returned to the maximum height, so we can leave it alone. But if you want to waste your time, I mean, you can do it for learning purposes. Now that you know the initial velocity and the final velocity, you can actually calculate what this time should be, right? Right, because you know that the initial velocity is that, here it is 0, and then we have the gravitational acceleration, so we can actually determine the time from there to there. And then of course whatever value we get here, we will add it to 0.64 to get the final answer there. But it's not a big deal, but let me just do it for the sake of being, you know, complete. So we know that we're going to have final velocity 0. By the way, this is squared. No, it's not squared. And then this one is minus 4,20 plus 9,8 delta t. Alright, so therefore our delta t there is going to be, we transpose this, which is going to be 4,20 divided by 9,8. So 4,20 divided by 9,8 is basically 0.43 seconds. And then this you're going to add to 0, not 0, but yeah. You're going to add it to 0.64. We're going to say 0.43 plus 0.64, and then it gives us 1.07. I mean, that's if you want to calculate it, but I've just shown you the procedure in case you get a question in your major exam. If you are doing that exam and you happened to watch this video, they may actually take this very same question and just modify it so that you can do a similar thing but in a more intense version. Okay guys, that's it. We've done the graph, so we move on. We don't want to spend time there. Yo, this section is boring though. Don't you guys agree with me? Momentum is boring. I don't like it. I really don't like it. It's too simple. Should be put in grade 10 somewhere and just forgotten in matric. We just apply the impulse situation and stuff. But I feel like this is really boring. Anyway, let's do it. So we've got 4.1. Okay guys, let's not waste time anymore. Now I told you two balls A and B of mass 250 grams and 300 grams. So these are all indicated respectively, collide head on. Okay, before the collision, ball A was moving at a velocity of 4 meters per second to the right, and the arrow is indicated, and the ball B at 6 meters per second to the left. Again, even if these were not they were not said in statements, the arrows pretty much mean the same thing. After the collision, ball A moved to the left with a velocity of 2 meters per second. So this means after these friends did their thing, this ball A was moving in that direction now at 2 meters per second. Then we want to know what is ball B. It was slightly bigger. What is ball B doing? So ball B is an unknown friend. So we're going to break it apart because we don't know what actually is this friend of ours doing. So in which direction is this one moving? We don't know. Great. So let's move on. Explain what is meant by an isolated system in physics. Again, textbook work, guys. You cannot be caught out by questions like this. So we can say an isolated system, basically it means it is a system in which the resultant force is 0. You can just say a system a system in which the resultant force acting on it is 0. Okay, there's plenty of ways we can put it, guys. I'm not gonna even make anything, so just know the resultant force is 0. Sometimes it's not really, what can you say, guys? Look, leave it at that. Isolated system, there's no external resultant force. Meaning it is 0. Okay, so that's just what it means. Leave it alone. Sometimes it feels a bit incomplete or cumbersome, but let's just move on. Calculate the velocity of ball B immediately after collision. So we're going to use the the energy conservation, the momentum conservation. So you can say sum of P before equals sum of P after collision. This implies that we have got M1 V1 plus M2 I don't like this M1 VI1. Lord, leave me alone. Anyway, so M2 M1 V1 plus M2 V2. Okay, just leave me alone, guys. I am not interested. Simply I don't know why they took away the U for initial and V for final, because that would have sorted this nonsense here. These people like trouble, eh? They like to complicate matters. Anyway, so boil A is 250 into, by the way, choose a direction. State somewhere that to the right is positive, okay? You have to say it, even if you're saying it here, and say direction to the right positive, and then you do your calculations. So this one was doing 4 plus this one is 300, and it was doing 6 to the left, so it's going to be minus 6 equals 250, and then it does minus 3, minus 2, sorry, minus 2, yes, don't let go. Ke eng jwale ntwena? Ai, o tseba ntho tsena di rata hampe hore o shebane le tsona. Hai, ha ke batla o shebana le tsona monna. Banna, nna ke kgathetse jwale ke tlo etsa final gymnastic ya ka. Ke tlo re V2 jwale. O tlo ba mang? E tlo ba this side, okay? This is 250 into 4 plus 300 into minus 6, okay? Then we will transpose this, say minus 250 into minus 2, okay? Then we divide this whole thing by 250. Okay, so I'm really not interested in too many things. So let's start 250 into 4 plus 300 into minus 6. So this is minus 800, okay? So this is minus 800 plus 250 into 2. Right. So this gives us minus 300 divided by 250. This is minus 1,2 meters per second, and then if it is 1,2, this is 1,2 meters per second to the left, right? So it means it hasn't changed the direction. So it's literally doing this, but it was slowed down a bit. Okay, not a problem. So made sense. So chances of being wrong is really not there. So formula somewhere, get a mark. Sometimes you get a substitution for each side because it's a little bit silly, you know. Yeah, and then you get a mark for the answer. Great. Next question. Is the collision between ball A and ball B inelastic or elastic? See this question, I don't know how many times I've done it, so you guys must have scooped those marks, because there was nothing to them. Now, is the collision between ball A inelastic? So now let's do the sum of EK before collision. Is going to be half of 250 of 4 squared plus half of 300 of minus 6 squared. Okay, 0.5 into 250 into 4 squared plus 0.5 into 300 into 6 minus 6 squared, by the way. But we're going to get 7,400 joules, okay? So EK, sum of EK, after, this is now half into 250. This one was now minus 2 squared plus half of 300, and then this one was like now 1,2. This is minus 1,2 squared, and then let's see what that is. So 0.5 into 250 into minus 2 squared plus 0.5 into 300 into minus 1,2 squared. We're getting just 625 joules, which is not equal to the sum of EK before. Therefore, the collision therefore the collision is inelastical, right? If you are, since EK is not EK of the system okay, so you know that word bafethu lento lena kodwa why mani ngiqala kabi ngimoshile ixesha yazi kule ndiyibhalelane nalento le okuthanda ukubhala nokuphapha nje EK of the system. Okay, it's not conserved. You know what I was trying to say there, guys. If you can't see it, I'm sorry. I am sorry. Okay. All right. Okay, so that yo the conclusion. Okay, 5 marks. Now let's move, guys. Yeah, well, losing time for no reason. Okay, let's try and quickly rush through this organic chemistry business. Now question 5 says consider the letters A to E, and then if we're looking at this one, there's a giveaway here. Once you say double bond, it's an alkene. Okay, alkene that is branched, not a problem. It's an alkene, it's branched, not a big deal. C4H10O, this could be an alcohol, aldehyde, could be a ketone. But if we're looking at this formula, the part before the hydrophobic end, basically it matches that of CnH2n plus 2, and therefore this becomes an alcohol. Okay, so we know that that matches that, isn't it? Definitely it does. So it means these other guys are screwed. They are screwed, and badly. Okay. Okay, now let's look at this one, C3, and then the CC's, no hydrogens. If those C's lack hydrogens, there's a triple bond there, né? You know it. So CH3C, triple bond C, then we have CH2, CH3. Yeah, it makes sense. This is what it looks like. So this is an alkyne. So basically it's an alkyne. So when you see something strange, you always want to interrogate it. What is it? Okay. Now, but2in or but2in, it's not but actually, it's but2in. So we know that that's an alkene with the double bond in the second carbon. Now when you see this story here, when you see this story, what is that? That already tells you and I were looking at a carboxylic acid. Okay, the COOH, carboxylate ion, there is it, yanalont. And then look at the last one. This is just a long chain alkane. There's only single bonds. Okay guys, so easy, you can figure it out. Now it says use the information in the table to answer the questions that follow. Write down the IUPAC name of compound A. Now we're going back, okay? We can see that, look, this is an alkene. Now what is the longest chain? Let's look at the straight one. 1, 2, 3, 4, 5, 6. So there's 6 carbons. Let's look if we're taking a side branch. 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5. Okay, so the longest chain is 6. So if the longest chain is 6 and the straight chain does the job for me, I don't look elsewhere. So I always look at that, okay? So now how do we number the carbons? We prioritize the functional group. So the functional group is closest to this end. So this should be carbon 1, 2, 3, 4, 5, 6. Ne? Substituents, there may be many, but they don't take precedence over the functional group. Ne? Great, so this is now a hex 2-in. Now there's a methyl group here, and there's a methyl group in there. So on carbon 4 and carbon 5, there's methyl groups. So we start with the substituents, right? Right. So we've got here 5.1.1. So this is going to be on carbon 4 and 5. So this is 4, 5. Dimethyl hex 2-in. Maybe that word didn't just come out right. Dimethyl hex 2-in. Okay, great. That's the name of the friend. Wonderful, wonderful, wonderful. So we're getting 3 marks. Of course, the substituents correctly numbered and correctly named, the parent chain correctly named, and the position of the double bond correctly identified. So those are the 3 marks. So let's look at 5.1.2. It says now letter that represents a compound that belongs to the same homologous series as ethine. Now ethine is an alkyne. Okay, that YNE says we're looking at an alkyne. So the alkyne in here is C. So you see, sometimes just identifying things, you are doing yourself a huge favor. So 5.1.3 says name of the functional group of compound E. Now, where is compound E? That is a carboxylic acid. So the functional group of a carboxylic acid is what we call the carboxyl group. Okay, that's the name of the functional group. Easy stuff. The general formula of the homologous series to which A belongs. A is essentially an alkene. So the general formula for alkenes is what? CnH2n. Easy, 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 easy. Let's move on. Now 5.2 says compound B represents a tertiary alcohol. Okay, so this is now compound what? Compound B, yes. Okay, we saw that it is definitely an alcohol, but now we're being told it is a tertiary alcohol. Okay, now write down the structural formula of B. So this is a very nice one. Yeah, so how many carbons? There is 4 carbons. There's 4 carbons. Okay, so let's start here. 5.2. We know that for us to have a tertiary alcohol, we know that the carbon that is bearing, let's do it here, the carbon that is bearing the OH group, sometimes you can write it like that, okay? Sometimes you can just write it bent. If you like, honestly, you can make it straight, it's up to you. But this carbon is bonded to 3 other carbons. Is it 3 other carbons? Yes, the carbon bearing this for a tertiary, it has to be a tertiary carbon. So there's a carbon there, and then there's a carbon here, and then there's a carbon here. So how many carbons is this thing anyway? It is 4 carbons. So we've got 3 carbons here at the moment. So it means we can add either this side if we like, or we can add that side if we like, or we can add this side if we like. It is absolutely up to us how we want to do this thing. You understand? Jy verstaan, leiding. So how you do this is up to you, really, as long as it is a tertiary thingy. So let's do this one like so. Okay, that is the one. So basically this is basically we can just simply say 2-methyl. Aye man, this is too many carbons now. There must be just 4. Why do I have 5 now? Man, you must not talk too much, man. Yeah, man, you talk too much, man. You brought the feel, bruh. Yeah, you're the scannering type, yeah. Hey, it's nie scanner nie, man. I do not scanner, so don't even think about it. I'm not those men. I'm not those men. So basically that is the structure we've got, okay? Yeah, I think it's fine. I don't know how I did not calculate properly, but this is it. So you can see here that you can look at it in terms of this propan. This is propan 2-ol. Okay, this is propan 2-ol. So this is now 2-methyl propan 2-ol. That's the name. That's the name, and it is tertiary. It is tertiary. Or if you like, you can look at it this way, that this is the longest chain. Then you're going to say this is now 1,1 dimethyl ethane 1-ol. In fact, this is ethanol, if you like. Ne? Yeah, this is 1,1 dimethyl ethanol, or ethane 1-ol, but it's already going to be on 1 carbon, so we can say ethane 1-ol or ethanol. Or you can say this is A2-methyl 2-methyl propane 1-ol. Okay, so those are the synonyms, by the way, so it's not a big deal, guys. Some synonyms are just synonyms. No, synonyms is tetantonye. And it, yeah, nisazi nesixhosa ba iwena sikhona phaya. Is tetantonye. Ngomabizwa, hayi man. Not amabizwa afane. Is tetantonye. Those are synonyms. They mean the same thing, right? Right. And then is omabizwa afane, they are called homophones. Is it? Omabizwa afane is homonyms. Yeah, there's homonyms and homophones, but I think it's homonyms. They sound the same in terms of the names, but they mean different things. Okay, all right, but synonyms, they are not necessarily spelled or pronounced the same, but they simply mean the same thing. Anyway, guys, I'm losing time and I'm talking unnecessarily. So 5.3 says compound D has a chain, right, and a positional isomer or positional isomers. Okay, define positional isomer. Oh, guys, can't you forgive me for this one if I don't do it? Can I not do this one, guys? I cartel, man. A positional isomer basically is a different position of the functional group within a chain of an organic compound. Okay, and that's what it is. So meaning these are the things that are just one and the same, except that the position of the functional group is different. Write down the IUPAC name of the positional isomer of compound D. Now let's look at compound D. Where are you, D? So we've got but2-in, but2-in, okay? So it could be but1-in, okay? So we know that this could be but1-in. So 5.3.2, this is going to be but1-in, okay? That's all, because those are the only two positional isomers, meaning the functional group is either in position 1 or position 2. I don't think it is ever going to be anywhere else, okay? So those are the only two positional ones. And then we know that we've got chain as well, okay? Not a problem. It says now write down the structural formula of a chain isomer, compound D, okay? Now we have a situation here, so let's do it here. 5.3.2, I should have skipped a space in there. Now remember, but2-in is 1, 2 double bond, you know, that is but2-in. Whether you're coming from this end is on carbon 2, whether you're coming from that end is on carbon 2. And but1-in is 1 double bond like this. So you see that one is there or there, it doesn't matter. So these are the positional isomers, but now we want something called a chain isomer. A chain isomer is going to be basically something that is branched. So we have to think about a propene, right? We're going to deal with it as a propene. So it's going to be like this. If we like, I mean, a propene can either be there, can be there, it doesn't matter, it's always on carbon 1. And then we're going to have 2 hydrogens there. And then here we've got 1, 2, 3, so we need the fourth. The fourth is going to be a chain like this. So sometimes you can do a few things, a few rituals to try and bring it alive. So we've got it all covered now. So you see, this is the chain isomer right there. So because, why do we say chain? I mean, looking at the chain as well, they are not of the same size. The other one is longer, the other one is shorter. You understand? So that's why it's called a chain isomer. So not a problem, guys. So this is it. So it's did they say structural formula though? Yes, write down the structural formula of the chain isomer of compound D. This could be the only one, because if you take this methyl group and put it at the end, it no longer becomes a side chain, but it becomes the longest chain. So it becomes a but1-ene. So no, we wanted a chain isomer, so meaning the chain should be different, but we should have the same molecular formula of molecular mass. Okay, that's it, guys. It says now 5.4, is compound C saturated or unsaturated? Let's look at C. Where is C? C is definitely unsaturated. It's an alkyne. So 5.4. We know that this is unsaturated. The reason is there is a triple bond between two consecutive carbons in the chain. Yo, cutting palikahle. Maybe this one is important to phrase it just right. Okay, guys, now you would have been told that it's time up now. They're giving you 5 minutes to finish up. So I mean, I think I took it easy too much. So what I was saying, there is a triple. In fact, if you like, you can say multiple. There is a triple or multiple bond between two consecutive carbons within. It is within, right? Or in. Let's write this within properly. Within the chain of the molecule. Of the molecule or the compound, ne? Hey, I intend this balayo ngoku simxakile. Xa ndibhalelana isingesi esininzi kangaka. Of the molecule, okay, the molecule, comrades, you understand. That is because there's a multiple bond between two consecutive. It doesn't matter. You don't need to specify between which carbons. We don't care at this point. Just go in general. Ne? Thank you. Now, this question now, 5.5 says compound F undergoes complete combustion. Someone asked me to do a detailed, should we say review, because I wouldn't call it a lesson. I'm not really a teacher. I'm good at reviewing things and analyzing things. So I would safely say I'm an analyst. Yeah, I like to analyze. Not good at teaching people anything, but showing them everything is what I do. Okay, so let's have a look at this one and think about it. Let's think about it for a second. Let's forget about what I wanted to say. So I'm going to do those videos, guys. I don't know when. I don't want to lie. I still have promised sequences and series review, but yes, it's time and the bars just throw me off. So I will find time to do it. So if you are subscribed, you are safe. If you're not, yeah, you will realize those videos when you already no longer need them, but they probably would have made a difference, ne? I think so. Okay, write a balanced equation using molecular formulae to represent the reaction that takes place. Now remember the word here, the key word is complete combustion, meaning there is nothing that, meaning oxygen is in excess basically. So there are some words that imply certain things in both physics and chemistry, so be careful where you are and what everything means. If they said incomplete, you know, you're forming carbon monoxide and water vapor, you know, as a gas. Or if they say complete, you know, it's going to be carbon dioxide and water vapor. Of course, stay tuned to, not stay tuned, but do tune in into the videos that I'm going to do on organic reactions. I think it's worth the pain. Okay, I will try to do those videos in a more comprehensive way. I will start off with these combustion reactions, do esterification reactions, and then all the other not so great but yeah important in betweeners. But those are the two main applications of organic chemistry, essentially combustion and esterification. The others are just interchanging between the types of molecules depending on your target, but not really of that much importance. Okay, so combustion F. So let's look at F. How many carbons? 1, 2, 3, 4, 5, 6. So we've got C6. H. Bangaki. But you know that this is an alkane. So if these are 6, that's going to be H14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's going to be H14. But count, my fate, don't take it too easily. You know, it's so easy to drop marks here. Then we're going to add oxygen. Remember, oxygen naturally occurs as a diatomic molecule, and you understand why it is unstable alone, because its outer energy structure is incomplete. So for it to be completed, it has to occur as a diatomic molecule by forming a covalent bond with the next oxygen atom. No problem. So you need to know exactly that we are heating here. So sometimes I don't know if you get penalized if you don't show that triangle there to show that we are burning this stuff. So, and then we're going to form a CO2, which is carbon dioxide. Remember, this is a gas, plus H2O, which is also a gas because it's in water vapor form. Now this is a liquid because remember, anything from 4 upward is essentially a liquid at room temperature, but the others are gases. So this is a gas. So if you are to show this, is okay, but you don't really have to. Even if you didn't show, I doubt if you'll be killed, but you never know. If you don't consult your exam guidelines, you will always not get it right. Now guys, the procedure here is to first balance the carbons. Now there's 6, there's just 1, so we need 6. Okay, then we balance the hydrogens. There's 14, there's just 2 here, so this must be 7, then it gives us 14. Now the last guy to dance with is the oxygens. They become a bit of a silly thing, but you look at them here, there's 7 oxygens. You see, once you get an odd number, it's a nightmare. So we've got 7 here plus 12. So 12 plus 7 is what? 19. Yes. Let me just double check. Sometimes I don't trust my mind. So yes, we've got 19. So these are 19. But now the problem is that if these ones are 19, 19 by 2 is 38, is it not? Yes. So it's 38. So now there's 38 oxygens against just 19. So that means we have to divide this by 2 to take it down to, you know what, the same 19 that we want, because this is going to be 38 divided by 2, which is 19. But now we don't divide by a fraction. It means we multiply by this as a common denominator. So this therefore tells us we're going to have 2C6H14 plus, when you multiply by 2, it just leaves 19 oxygen molecules, which is a total of 38. And then here we're going to have 12 molecules of CO2 gas I will teach you guys a lot about this a little bit later. So 7 times 2, this is going to be 14H2O gas molecules, because that is essentially water vapor. It's not just water, but water vapor. If you pressurize this, it becomes liquid, is it not? Yeah, when or you drop the temperature. Anyway, let's look at this thing. Is it now balanced? The answer is a hell yeah, because we've got how many carbons here? 12. There's 12 carbons there. We've got now 28 hydrogens, and then we've got 14 by 2, it's 28 hydrogens. We've got 38 oxygens. This is now 12 by 2, which is 24. 24 plus 14 is 38. So everything is perfectly balanced. So this is your answer. So you only write this in your answer sheet, okay? This is what you do on your rough work, because you are trying to work it out, but I'm just showing you the process thereof, okay? Not a problem, guys. So that is it. So easy, 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 easy. Now let's look at this one. Okay guys, let's keep moving. Now the table below shows the results obtained during a practical investigation. 2 experiments were conducted to determine the boiling points of compounds under the same conditions. Okay, and the key was to look at the boiling points of compounds, essentially different compounds. So let's look at experiment 1. We've got A and B. So we can see that this COOH cap right there is the same as this one over here. So we're looking at carboxylic acids, okay? See, there's a 2 here and 2 outside. It means this is within the chain, okay? It's not a side branch. You will see a side branch by this having a 3. And then when we look at the other one, this is an alcohol because we've got an OH here. So these are alcohols, okay? Not a problem. Then now we're talking about the molecular mass and the boiling points, okay? Now between A and B, you can see this is the same homologous series but different chain lengths and essentially different molecular masses. And we can see here, the higher the molecular mass, the higher the boiling point. The shorter the molecular mass, the smaller the molecular mass, the smaller the boiling point, or the lower is the boiling point. Then for experiment 2, we've got C and D alcohols again. If we're looking there, we can see that this is a 2 there with a 3 outside, so that is within the chain. So this chain is longer than the one in C, and for the same reason we can see that the boiling points are forming that. Now a grade 10 question, guys. Define boiling point. I don't think I want to. I've been doing these definitions for too long and I've been wasting time. A boiling point is basically a temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. But for the sake of just doing what we do best, so let's just do it. If I start showing energy, how much more you guys, because I'm supposed to instill enthusiasm, isn't it? Yeah. So boiling point is a temperature at which the vapor pressure, my pressure is not the best, vapor pressure of a substance is equal to the atmospheric pressure. Okay guys, I tried to write, but you know my writing has never really been the best, especially when I'm not relaxed, but I'm gonna try and improve, okay? It's not that my writing is terrible, it's just that I allowed it to deteriorate it wasn't really bad, but yeah, I kind of allowed circumstances to force me into messing it up, and now it's second nature. Every time I feel a bit overwhelmed, it just deteriorates fast. Okay, apart from the conditions for determining the boiling points, state the controlled variable in experiment 1. Apart from the conditions for determining the boiling points, state the controlled variable for experiment 1. So what was controlled here? We can already see here that it was the homologous series, or should we say the functional group. It is the same throughout. That is the only thing that stays constant. That's the controlled variable. Okay, so we can just simply say in experiment 1, we're looking at the functional group. Or you can say the homologous series. Okay, but I think it's fair to just focus on the functional group. Okay, so not a problem. 6.3. Now we're told to write down the general conclusion of this investigation. General conclusion. We can say here, the higher the molecular mass, the greater is the boiling point. Okay? Or the longer is the chain length, the greater is the boiling point. But since here we talked about the molecular mass, let's just use that and say the higher molecular, the higher the molecular, the higher is the boiling point in each experiment. Always attempt to be as comprehensive as you can with your answers, because you know what? That is very lovely. Even if you're talking nonsense at times, it just grants you some, because you show that you really care to do this thing. It's not a pain in the butt. It's a joy in the heart. Okay. And an excitement or stimulation in the brain. Now, how can we not, absorb that energy from your writing and give you even what you probably didn't get, but just because you showed enthusiasm. Anyway, it says now, which compound will have the highest vapor pressure? Now, we're looking at these ones in general. The one with the highest vapor pressure, it must essentially have the least boiling point, and that becomes compound A. Okay, because you see the boiling point is less, so it means for a particular temperature that is closer and below, above that boiling point, it will essentially have a higher vapor pressure. The others will tend to resist going into a vapor compared to A. So we can say compound A. Okay. So 6.5 says now the boiling points of compound B and D are compared. So we're looking at B and D. Okay. So you see this is an alcohol and that is a carboxylic acid. And now let's look what is so special about these ones. It has how many carbons? 1, 2, 3, 4. Okay, so this is butanoic acid. This one has got 1, 2, 3, 4, 5. So this is pentane 1-ol. Okay, 5 against 4. Okay, not a problem. Now it says write down the independent variable for this investigation. What are we changing basically? We're changing the functional groups. Because as for the chain length at this point, you can see that they are having the same molecular mass, which is, okay. Yeah, it is like that. So they have the same molecular mass. I actually didn't notice that. So if they have the same molecular mass, it's a fair comparison, irrespective of the chain length, so to speak. Okay. So now what is the story there? So the independent thing is their functional group, because that is what is changing here. Or you can still say homologous series is one to the other. But I think functional group is what matters here at this point. Homologous series is just a group general formula, which not necessarily is the big deal at this point. But the functional group is the most specific one, because it imparts these certain phenotypes of our compound. If it was to be a gene, we would say the gene, okay? But genes are essentially a constellation of these, organic compounds. You will see when you do organic chemistry properly in university, where you're going to be looking at nucleic acids and looking at their structures in terms of organic chemistry. And when you're doing biochemistry in second year, some universities call it metabolism or metabolism, if you were to pronounce it, in the varied ways across the world. At the end of the day, it's metabolism. You will learn a lot about biochemistry, and you'll start to really, really, really love the fact that you chose education over being a slave, okay? Anyway, nonsense talk is creeping up again. Now, fully explain the difference between the boiling points of the two compounds. I hate this question now, not at this day of word, but we're going to do it. 6 point so this was 6.5, this is 0.1, okay? 6.5.2. do I have enough space? No. And yeah, I knew I was gonna run into problems. Okay guys, let's have a look. I'm gonna point out a few things here. Let's say a compound. Now, I'm going to use D to compare to, I'm going to use B to compare to D. So we can just say compound B, compound B, okay, has two more sites for action of strong hydrogen bonds or bondings, for hydrogen bonds between its molecules compared to only one site in compound D, okay? So compound B has two more sites for the action of strong hydrogen bonds. Maybe we can write here that in addition to weak London forces, because the weak London forces are still there, but it has two more sites. So please put this bracket before here, that it has strong hydrogen bonds in addition to weak London forces between its molecules compared to compound D. Number one. Number two, we can say therefore more energy is required to separate molecules of B than is required for D. We can say therefore D therefore B, therefore, what am I saying now? Therefore, compound B, okay, again we're talking about compound B, we'll say we'll have a higher boiling point than D. Done. I think, guys, as much as my writing just started fading there, we can see clearly that the boiling point of compound B was higher than the one of D, and it is because there's two sides of hydrogen bonding in B than the only one side in D, and as a result, less energy for D and more energy for B, and hence they are differing boiling points having the same molecular mass. Okay, great stuff. Let's move on, guys. That's the 3 marks. Now let's finish up. The following flow diagram 1, 2, and 3 represent organic reactions, which I'm going to teach you about not so long from now. P and Q are different organic compounds. Yes, Q is the major product, is the major organic product. So it means some rule of some kind is going to be applied. Then we've got compound P as the starting, and then it undergoes reaction 1 to this one. Okay, but now we've got an oxygen and a hydrogen that are doing stuff that we don't understand. Yewena, what are you doing? So once you see that OH inside the chain, it is the OH as a substituent, and you can tell that this is an alcohol, essentially. Okay, so we are happy this is an alcohol, and it's essentially a secondary alcohol because this OH is in between somewhere. And by the way, this OH, as it is attached to this carbon because it always follows the carbon that it is attached to from left to right. Okay, that's not a problem, and we know that this is an alcohol. So whatever this compound is, if we formed an alcohol, this is probably a hydrolysis if this is a haloalkane, or if this was an alkene, this is hydration. That's fine. And then, so it's probably hydrolysis or hydration. So we know that we're looking at those possibilities. Hydrolysis or hydration, depending on what compound B is. But this is your thought process. And then we're going to say, okay, compound B to compound Q. Now here we can see here something came out. But now this thing that came out, this thing that came out, it has a bromine in it. And there's water that came out. So basically this is an elimination reaction of some kind. But now when we eliminate such that there's smaller little things that came out, and if there is a halide atom, or you can say halide ion, or you can commonly say halogen, but the halogen is a diatomic version of this element of group 7. Potassium is basically just sitting there because something that went with potassium got lost in the process. So we can see that this type of an elimination reaction is saying that this is a haloalkane, essentially, because we can't eliminate a bromide ion or bromide atom if it wasn't there in the first place. Potassium is simply a spectator ion of whatever we added to eliminate here. But we know that for this one we always add KOH or sodium hydroxide. So this is how it happened. So this potassium came from this guy, right? We used a strong base, but this strong base, for it to eliminate, it must be concentrated. Okay, it can't be dilute because this dilute one is what we use here. Okay, we use a dilute strong base when we are eliminating, when we are doing a substitution reaction. So a hydrolysis reaction here is basically a substitution reaction, whereas a hydration is essentially an addition reaction. Okay, but I think hydration, it depends on what we have. Okay, because you can still hydrate by doing a substitution, you know. So I wouldn't be too happy with this one, but what we know that this is a substitution reaction as a result. Okay, so substitution, now we can tell that if this is a haloalkane, it is hydrolysis reaction, which is the name of the type of this reaction here, which is a substitution reaction. So do you see, when you investigate, you just know what you're doing. And then now if we took compound Q, we know that this is definitely going to be, if we remove we do dehydro, this elimination is basically dehydrohalogenation, D double H. So basically we're going to form an alkene here. The major product is going to be an alkene. This alkene to end up here, it means we hydrated it as a form of an addition reaction. Okay, great. Now we understand each and every one of these reactions, and in fact this guy is now eliminated. At first it was a possibility, but it no longer is, because we discovered what is going on. Okay, so make a habit of walking through the flow diagrams before you attempt any questions, or you will die, I promise you. Name the type of substitution reaction. Sometimes I wish they can stop this. They like to do this in KZN. Their questions are always like this, very silly. They should just say, name the substitution reaction represented by reaction 1. And we could tell that it's definitely a substitution, but it is called hydrolysis. So that is naming it. But to say type again is crazy. Anyway, it's fine. They just like to irritate me. So it's fine. It worked. You got what you wanted, which is to really make me say something which I really am never gonna say. I'll just scratch whatever you wrote, which is stupid, and put what is sensible. I hate senseless additions or countless additions or unnecessary, you know, tautology or wording or beating about the bush, you know. Please, people, learn to mean what you say so that people can also learn to get to the point. I really don't have time nowadays to listen to a long, unnecessary story. Anyway, I'm doing it too. I'm talking shit. Sorry guys. I'm not rude, but you know what? Yeah. Write down the structural formula of compound Q. Wow. So we're going to get a glimpse from here. Okay, this is what is going to give us an idea. So we've got CH3, CH2, and then C, which has a hydrogen, and then an OH here, and then we've got CH3. Okay guys, anyway, I'm just being silly now. I'm just going to try and not be too silly. So our alcohol is like this. So this alcohol is the guide to everything. So remember, when we're doing an elimination, a substitution reaction, So we've added something. We substituted something. So it means this guy came out as a substitute of a hydrogen that was here. So it means here there was a hydrogen for us to end up like that. Okay, there must have been a hydrogen. There must have been a hydrogen, and therefore we moved it and put a is it? No, where there is this guy, there was the halogen. Sorry, there was the halogen here. That's where we lost the halogen. So yeah, there was a halogen here where the OH is put. Okay guys, yeah, this will replace the halogen. This will replace, yeah, it's essentially not even changed. It remains what it is. So this is what replaces the halogen. Okay guys, not a problem. So now this tells us that we've got our compound P as 1, 2, 3. So here there was a bromine. How many? 1, 2, 3, 4. Okay, so this was the story here, of course, with hydrogens there. Hydrogens there. I'm trying to figure out now if I'm not making an error here, because yeah, I'm trying to think now what happened here. Yeah, but this OH substituted the halogen, definitely. I'm confident of that. It substituted the halogen. So this is not like an addition reaction or anything. We simply substituted something, just one. We don't substitute two. So we substituted this one because this was already saturated. Yeah, the halogen was there. Now we removed this halogen, and then we're going to when we're doing the elimination reaction here, we follow the so-called Zaitev's rule, isn't it? Yes. So when we eliminate this guy, we're going to eliminate the hydrogen, or the what we call a hydrogen from the carbon with the least hydrogens. You see, these ones have the most, so we can't take from these. We will take from this one. So this is the next guy. So we essentially took these guys out. Those are the two guys that were eliminated. So meaning the double bond is going to be there for compound Q. So for compound Q is stuff like this. 1, 2, then there's a double bond here. 3, 4. Okay, that is the stuff. That is the stuff. And then of course it's an alkene. So 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3. If you like, you can just take this hydrogen and put it here and make it what you call a trans. This is cis, because these two hydrogens are actually on the same side across this double bond. So we call this cis. When they are like that, we call it cis arrangement. If this was to be here, so to speak, you talk of a trans. One is on the other side, one is on the other side. That is the stuff you're going to learn at university, okay? Just adding information every now and then. Anyway, so this is our compound Q basically. So do you see how long it took? You had to come from here, you work backwards to there, and then you work forwards. But of course you're using Zaitev's rule when you are taking things away. And when you are adding things back, you use Markovnikov's rule. Alright guys, I don't want this video to be longer, so let's just move. Name the inorganic reagent used in 3. the inorganic reagent used in 3 here, if we hydrate it, it's H2O. So they said name, so it's water. Okay, I don't know what happens if you write the chemical formula. Anyway, that's the story. Now write down the type of the reaction. The type of the reaction. Now you're talking, represented by reaction 3. We said it's an addition reaction. This is 7.4. Okay, now 7.5. Okay, let's look at 7.5. Says now the same inorganic reagent used in 1 and 2, and we can see here that it is KOH, because we just wanted to keep it simple, and they just did the same. Potassium hydroxide, that is the inorganic reagent that you add there. It says name or formula of the inorganic reagent used. Name or formula. So 7.5.1. If they say a formula, just say potassium hydroxide, KOH, or you can write the word potassium hydroxide. Okay, but you don't write both. Okay, you either write the name or you write the formula, not both. If you write both, you get 0 on it. Don't be surprised, because this instruction is binding. If it says name or formula, that means either one of the two, but not both. I'm writing both for your own benefit, but don't do it. Do just one. Okay, now one difference between the inorganic reagent used in reactions 1 and 2. Of course, we know that in reaction 1 it is dilute for us to to substitute. It is concentrated to eliminate. So for reaction 1, you can just write 1. You can just say KOH is dilute, and then in 2, KOH is concentrated. Okay, is concentrase. Now that's it. Okay, one difference between the inorganic reaction. Okay, you can say the only difference is the concentration. When they say one difference, yeah, doch, but they're saying 2 marks at the same time. One difference. So you can just say, therefore the essence of this question is that to say the only difference is the concentration. So the difference is the concentration of KOH. We can say the base. Okay, I don't know, guys. You can answer it here, you can split it apart. I am not too sure, honestly, but when they say 1, I would gravitate towards this answer and say the difference is the concentration. But in Palezom Kalam food, oh my god, the Palezom Kalam Kilek Hamola Kaman, whatever. So we can say the difference is the concentration of KOH used in each reaction. So I think this answer is better than this one. This one is more specific to each, but at the end of the day, they are just different in that the concentration is the only thing that's different. One is concentrated, one is not concentrated. So I would perhaps write that answer. Great. Now let's look at, write down the IUPAC name of compound P. Yes, now there you are. So you see our bromide atom is on the carbon 2. We always prioritize the so-called functional group. Now I have a problem, guys, with the way your books teach you haloalkanes. They say you regard this as just an atom and not the functional group, and therefore you take it as a substituent, which is ridiculous. Okay, it's really stupid. I don't know why they say that, because the functional group is what takes precedence anyway. Okay, but now they always want to say, if they have other side branches closest to, say, a particular carbon, and then this one is far away, even though it's a haloalkane, you're not going to prioritize it. Then what is the point of saying IUPAC naming says you're prioritizing a functional group? And by the way, what is a functional group? By definition, it can either be an atom or a group of atoms, or even a type of bond between the carbons in the chain that imparts the physical and the chemical properties of a molecule. So if you're going to disregard this and yet it changes the behavior of that molecule, then what the hell? What the hell? So some books, I don't understand why they write them. They write what? I don't know why some books are written the way that they are written, because it's absolutely ridiculous. I wonder if those people ever sit back and think about what they're saying or doing, or they're just simply copying a book from elsewhere, because there's that thing anyway. People read a book from somewhere overseas. If it is written that way, then they copy it like that. But they don't interrogate what is the sense in that, because if we have a system of naming organic compounds, then why are we flip-flopping then? Because we should just keep things as standard as possible to avoid problems, is it not? Anyway, guys, that's just my take, but it's not supposed to be correct anyway. So you are told what you are told, but I'm telling you what I'm telling you, okay? So you decide who you believe, me or your book or them who teach you. But in any case, a smart student would listen to their teachers and their books and not a babbler like me, okay? Because I will tell you things that are going to leave you crying, and you'll blame me when it backfires. I can defend myself. I don't know if you can, but I'm arming you with the tools to do that anyway. So I'm not just telling you poison, and I'm not giving you the instructions of how to use it, isn't it? Then if you breach the instructions, then it's your own endeavor. But I've given you all S. All right, guys. Enough of the talking. So I want the IUPAC name. So my problem is that with this structure right here, so let's just change stuff, I don't know. This thing has a tendency to just irritate me. I want this thing to mark, to show where I am. So here we are. So if you're looking at this structure, basically, we will prioritize the side that is closest to this bromide atom. So it means we cannot come from this side, because it becomes a third carbon. But if we come from this end, it becomes the second carbon. So this means we are going to name this one as carbon 1, 2, 3, 4. So this is 2-bromobutane. Simple as that. We were answering what question, by the way? 7.6.1. 7.6. Where is? Oh, yeah. So 7.6.1. So this is 2-bromobutane. Okay, maybe let's write it better. Okay, 2-bromobutane. Okay, you can't say 3-bromobutane, because again, you always, of course they tell you regard it as an atom or a substituent, meaning you may not prioritize it if others are closer to a particular end than this would be, which is ridiculous, I said, and I'm repeating it. It's absolutely nonsensical. But anyway, whatever they teach you, guys, stick with it, but just know it's rubbish sometimes. So yeah. I'm putting my head on the block on this one. It's ridiculous. I hate it, by the way, because I hate books that flip-flop. What are they really teaching? Honestly. Of course, it's a minor issue, but it's major for me because it confuses pupils. And once you leave them confused, then you wonder why they don't perform. Oh, there's a black widow spider here. That means killing. Okay, I've nailed it. I don't know why it was here anyway. It bit me before. And my toe was almost rotting. Hey, that was a bad one. Okay, guys, so this is 2-bromobutane. Easy, ne? So you're getting a mark for this substituent. But this is a functional group. For me, it takes precedence. I always do it that way. You will see that in almost every video I did. I prioritize the halide atom on a haloalkane because I understand the definition of a functional group. Those who do not, they will tell you otherwise. Ne? Great. Now let's do the inorganic product of a reaction 3. So what is the inorganic product of reaction 3? What happens when we add the things in there? Remember, we just take water there and add it there, or the organic product of reaction 3. Yeah, when that is now, we want the IUPAC name, yes. So we want the IUPAC name of this one. So again here, we always prioritize the functional group. So it means this is carbon 1, 2, 3, 4. So this is going to be butane 2-ol. Is butane 2-ol. Okay. So that is the one. That is the one. I was surprised now. Where's the inorganic one? I'm so used to these ones. So again, here you're getting a mark for the parent and then the position of the functional group. Okay, guys, that marks the end of our review of this paper. For me, it looks like a good paper. So just leave the nonsense that you heard me say. This was an excellent paper. And by the way, I have seen that my videos of the videos of my papers from KZN are doing better than the videos elsewhere. This was an excellent paper. I did not find mistakes on this paper at all. Spare that there were just some lousy, repetition type of issues like that. Name the type of substitution, like things like that. Other than that, the paper was essentially smart, well moderated, less nonsense, more, good stuff, more good stuff. So guys, this paper was superb, and I congratulate the guys from the KZN. They upped their game. I like it when papers are this bulletproof. They don't have a lot of controversial questions, because what's the point? These guys are not yet scientists. They're not going to sit across the table with the scientist and make an argument and argue their position. So they simply depend on the marks they can score. So I feel controversial questions should be booted out of the exams so that we leave standardized questions. We can make them tricky, that's fine, because we're testing their understanding than just knowledge. So it's good, but no controversial questions, please. So KZN has done it. It's the first province I see this year to have done a good job. I haven't seen the Eastern Cape one. I will look for it and find it, but I won't do it, ne? Now, my videos for the Eastern Cape papers are not doing well, so I hate to waste my time doing things that don't add any value to anybody. So the goal is to reach as many people with as much of the good information. I wouldn't say I have excellent information. I'll just say good information that can transform your thinking and your approach. As you can see, I make an attempt to write down how to answer, because at the same time you need to be taught on how to answer. I see a lot of your teachers and a lot of guys who do tutor, which is not a problem. I'm not against their techniques, but I'm against the fact that they write here and there, everything is just all over the show, and then the student has to wrestle, the organization of the writing eventually. Remember, these kids learn from you guys, so whatever you do, they tend to follow you. So you find that their work is haphazard, is all over the place in their answer books. And then we start complaining that, you guys are illegible and stuff, but we show them that. So we need to be more organized. I was fortunate, honestly. My teacher showed me you see the way I'm showing you things. My maths teacher in high school is the reason for this, because he had a systematic way of doing things, and I adopted it, and it worked. Okay, especially for someone who writes as badly as I do. Having a bit organized, in your approach, it kind of makes it a bit more palatable, as horrendous as it may be. Anyway, guys, goodbye. I hope you enjoyed the video. I hope you have learned something and that you're going to continue to practice. As I said, I will do a bit more detailed reviews of the organic reactions, because it was a request by a student, and I hope anyone who bumps into it may learn a thing or two. Of course, there's many platforms that you can learn from on YouTube. There's a good friend of mine, Mr. Chauke, Emmanuel Chauke. Okay, so he has some maths videos there. You can go and have a look, and make sure you take the advantage of those, attempts in demystifying some challenging areas in these subjects. Okay, guys, I took longer than I planned. Thought I was gonna do maybe 2 hours and 30 minutes, but yeah, took me a while because I started talking nonsense. As always, tried to keep it down, but kumsila wembol makhasana xa ubona ubisi vele uxhume mntakabani ubungawubophelela. So ndizonixelela. Otherwise, goodbye and good luck.